Good evening, students. Let's start with the class. In the previous class, we had seen two types of frictions. That is, one was static and the other one was kinetic. This is indicated by f of s. This is indicated by f of k. We saw that static friction comes into picture when the body is at rest, suppose. Okay, till now there is no friction. Okay, only once you start applying force, then the friction comes into picture. Otherwise, right now there is no friction because the body is not trying to move. As long as the body is at rest, your any kind of friction is zero starting. But the moment you start applying some external force is indicated by your capital F. What will happen? This one will try to oppose it. So starting only when at rest and then you are trying to apply force, F of S is produced against the direction of the force which you are applying. You keep on increasing the force, suppose F1, F2, F3. Just keep on, you are starting with a small force, then as you increase, this also will keep on increasing. But at one point, there will be some limit which will be reaching, that is called as f of x max. Okay, so suppose if this, I had given example, if this is 5. So if this is 1, this will become 1, 2, 2, 3, 3, and the moment it crosses 5, then this force is no more into picture, then your external force will overcome this force and then the body will slide in front. The moment the body starts sliding in front, this friction, static friction goes, it reduces and goes, and then what comes into picture is whenever this is in motion, the f of k starts. At rest, it is static friction. At motion, it is kinetic friction. And this always remains constant. This never increases or decreases. This is constant. Next is just the theory part based on this. Laws of friction. The magnitude, just like some notes, magnitude of limiting friction. Limiting friction is that f of s maximum. It depends upon nature of surface of contact. And state of how much rough it is. State of roughness. It is independent of area of contact. What I told you in the previous class, that suppose if any two surfaces are into contact, it depends on this surface area. And this is called area of contact. And this is called surface area of contact. So friction depends on this part, only this much, not on this. Okay. So magnitude of this friction, how much friction it can give, depends upon how rough the surface is. Depends on the surface of the contact and the state of its roughness. And it is independent, it is not dependent on area of this contact. Like the first note. Second one, force of friction is tangential to the two surfaces in contact and acts opposite to the direction of motion of body. Tangential means what? There are two things. This is called as tangent, normal or perpendicular or vertical. Okay. Suppose with reference to this line and in the direction horizontal or tangential means the same. Vertical means it is called as normal or perpendicular. Okay, normal means nothing but like a perpendicular. And what is this? Tangential means in the direction like this, horizontal direction. So force of friction is always if the two surfaces are in contact, no friction force direction will be like this. If you are applying external force, it will not act vertical. Your friction force you have to always indicate like this in the horizontal line. I have never mentioned here saying f of s like this. Okay, I've always mentioned like this, either this direction or this direction, whichever way, opposite to the force applied. So if your external force is applied this side, then friction will be on the opposite side. So force of friction is tangential, means horizontal to the two surfaces in contact and acts opposite to the direction of motion of the body. So if your body is moving like this, friction will be on the opposite side. And the third point, value of limiting friction between two given surfaces is directly proportional to the normal reaction. What it means is force is directly proportional to N. Some of the this also letter is used R. Both mean the same, normal or reaction. If your teacher is using the letter R, you can use R. Using N, then you can use N. Both has the same meaning. Either called normal or either called reaction. So the formula to calculate any friction, you have to remember this formula. We have problems based on this. For that, you will have to know this. So while solving the problem, you have to take care of certain things. Okay, so that I'll tell you. Now this nu can be either S or K, depends whether this is of we are calculating static friction or we are calculating kinetic friction. So this could be, if this is f of s for static friction, we are using the formula, then this will be f of s. So this will be nu s. R, instead of R, we can use N also. Everywhere we'll be using N. We can use the letter N. If we are finding, this is for static. For kinetic, it will be F of K. So you have to see what you have to calculate. Based on that, you have to change the letter. In case we have to calculate this. Now, when we have to calculate static, when body is at rest, okay, or initial value. So what we'll do is, suppose if you have to find a static friction, no, we want to know if the body is moving or not moving. So you have to take care of certain things, two conditions. Suppose if your f of s maximum, if you calculate, is greater than your force applied, okay, if this is this, so body is at rest. What basically it means is, if that maximum limit friction force is more than the force applied, definitely the body will not move. No, the example, you are putting a force of 5 Newton suppose, and this one's f of s maximum limit is suppose 10 Newton. Now f of s is more than what you are applying. So what you have to do, you have to apply more than 10. But now what is happening, this fellow is more than this. So obviously your force is not enough to push the object. The body will remain at rest only. Okay, or you can say body will remain at rest. But if your f of s maximum becomes smaller than this one, then body starts moving. So if the body is moving, definitely kinetic friction will come into picture. Will be applied. If the body starts moving, definitely then kinetic friction will come into picture. The moment it crosses the limit, then it will be kinetic friction. Before that, it will be static friction. Now under kinetic, remember one note. Suppose look at this condition, okay? A body is moving. It is in motion, okay? And then it has to come at rest. Okay, we'll directly give a condition. Has to stop, suppose. So whenever this type problem is there, a moving body stops. Okay, suppose if the body is already moving and now it want to stop. So what you have to do, obviously, if any body, when it will keep on moving, when there is a force which has been applied, no, you're pushing it, that's why it is moving. But now if I want to make it stop, so what I'll have to do, I'll have to remove this force so that the body stops. Okay, consider you were pushing and pushing, but now you have to make it stop. So definitely whatever force you're applying, you have to remove. So that means what? In order to stop, the external force is removed. Okay, if you want to remove this force, so in this case now there will be a problem. We have to calculate acceleration. Okay, so you have to take the value as negative. Because why? Now when it wants to stop, no, so it's like the acceleration will decrease. Right. This will be the formula. Later again when you are solving the problem, you'll understand. Now this I'm giving as per, like, whenever you want to revise, you can read this quickly. The acceleration you have to take negative. Minus f upon m. When this is the case, okay, when a moving body has to stop. Remember this. I will solve problem. Okay, before that, one more thing I'll do. Suppose if you want to calculate angle of friction. Consider two contact forces. Which are the two forces we'll consider? Normal friction. Now suppose this is the body. Okay, it's in contact with some surface. So there will be definitely some friction over here. So how we indicate the friction? Always tangential, I told. Tangential means in the horizontal direction. So we'll consider f of s like this. Okay, or we'll consider on the same line here. So this is your f of s. There's a friction between the two surfaces, and normal is always perpendicular to the surface. So when no force is applied, no friction. Whenever there is no force which has been applied, there will be no friction. So when will the body start moving? When applied force is more than your maximum force. So we'll consider this as f of x max. You can just write this as f of x max. When friction will come into picture? Whenever the body starts, whenever you're applying some external force, and then the body will move. Okay. Whenever your applied force overcomes the frictional or the static friction force, the body will start moving. So if you notice, f of s max is what? Nothing but your tangential. Okay, also called as the horizontal component, and normal force is the vertical component. Now I want to calculate some angle theta. So what I'll do, see, consider these are like the two vectors. This is one vector because both are forces, no? Forces are nothing but vectors. So this is your second vector. So between any two vectors, I want to find the common vector. Okay, then it is always called as a resultant. So I'll try to find what is the combination of these two vectors. So average would be like a resultant. That will be result between these two vectors. Anytime we want to calculate the main vector between any two vectors. So these are your components. So the main vector is called as a resultant. Now let this be theta. Let theta be angle of friction. Now we'll complete this diagram, parallelogram method. Finally, my aim is to find what is the value of this theta, because we are calculating angle of friction. So this, I just complete the diagram. This is your R. Using parallelogram, just complete it. This is your f of x max. This is your n, this distance. Automatically, opposite sides are always equal. So this will be n, and this will be how much? F of s max. Opposite sides are always equal. So if this distance we considered as f of x maximum, and this was your normal, so obviously this will be also not equal to this, and this will be equal to this. And this is nothing but your r, main one. Now if you notice, this is perpendicular, and this we have considered as theta. So when the body is about to move, just when you're applying force, when does it start moving? When it crosses, when this is equal to your applied force. The moment it start crossing, then it will start moving. So exactly at that moment, suppose this is 10 and your applied force is also 10. So now when the moment it becomes 10.1, it will move. So this is just about to move, and the next second, next 1 point, the body would start moving. Even if this was 9, it would not move. Even if this was 9.9, it will not move. Exactly like 10.001, it would start moving. So the frictional force will be maximum. what is the formula we have studied? F of S. I told you this is the main formula which we have to know. So in this case, what we'll have to take it as maximum, because we are calculating at that moment when the body is about to move. That will be now from this diagram. Okay, just consider it as 1 and keep. Now from the diagram, from the figure, we'll see what is tan of theta. Tan theta is nothing but opposite upon adjacent. So which is the opposite side? So tan theta is nothing but F of S maximum. That is nothing but a maximum frictional force, and then adjacent is normal n. Now put this value of F of max here. Mu S. From where we got this? From equation 1. Value of F of x max is nothing but mu S into n. N and n will cancel. What will get? Tan theta is mu S. So theta will be tan inverse of mu. So this is the angle of friction. If any doubt, you can ask them. Okay, we start with the problems now. These are all based on friction. The first question, a body of mass 4 kg is set into motion on a horizontal surface with the help of 10 Newton. Find the coefficient of kinetic friction between the two surfaces. A body of mass 4 kg is set into motion by applying what? A horizontal, on a horizontal surface. It's like a pushing the body with the help of 10 Newton. So find a coefficient of kinetic friction between the two surfaces. Now the only formula related to this friction which we know is F is nothing but mu into n. Now obviously kinetic friction has been asked. So which formula? Even if they don't mention which friction, it's understood. The moment anything is in motion, a body is in motion means the body is moving. So which friction will come into picture whenever body is moving? Obviously kinetic friction. So even if they are not mentioned, it's understood that you have to calculate your kinetic friction. So this will be K, this will be K. Now we know only mass has been given. Four kg and F is given as 10 Newton. So whatever force you are applying is capital F. So force applied is 10 Newton. Because with the help of 10 Newton we are trying to move. So that is the force which is been applied on the body. Basically it means there is a body of 4 kg and you are applying 10 Newton on it. This is the only data that has been given. Now first we can calculate this N. What is this? Because the entire friction is mostly dependent on this one. Okay, here just in the bracket now this was given, okay. Mu of K is given to you as 0.2 for the question now at the side. Mu of K, okay, coefficient of friction has been given to me as 0.2. This we know, mu of K is 0.2. But this F and this F is not same one. This is friction and this is applied force. We don't know this, we don't know this also. So we have to calculate N first. So we'll draw this diagram again. This is 4 kg. So any this at rest, suppose, or whether it is moving, these are the two forces we have already studied. One is that it is mg, that is the weight of the body, which is just trying to pull down from the surface, and perpendicular to the surface will be your N. Oh, this is a beta. 1 second. Different question. 1 second. Fine, just cancel this. Find kinetic friction between the two surfaces. Find kinetic friction between the two surfaces. And mu of K is given to as 0.2. So basically we have to find what is F of K. So we know this force, we know this is also there. What is that? 10 Newton. Now remember this, whenever you have like this, they are always equal and opposite, I told you. So vertical forces you have to always equate with vertical forces. So what is going to happen? As per this, N will be always equals to mg. Already we have solved problems based on this. Huh? We have to calculate your N. So mass is nothing but 4 and gravity you can take as 10. One you can take as 9.8 also. Consider now this is 40. So N value is 40. Next, and we'll calculate this now. So kinetic friction is nothing but mu n. So this we already got as 40. This is given to me as 0.2. So kinetic friction is 0.2 into 40 will give you 8. And unit is always Newton, no? Because it's a force. So we got the answer. Kinetic friction is 8 Newton. Now for the same problem, no, if in case acceleration was also asked, till friction, kinetic friction is asked, you have to stop till here. Now suppose for the same, calculate suppose acceleration of the block. At what speed it is accelerating, we have to calculate. Now draw the same diagram again for acceleration. This is mg, this is n. So now definitely this is moving. So this is 10 Newton. Now what is going to happen? There's a frictional force which we have calculated. Obviously this is your main F applied. Your friction, this kinetic friction will always be opposite to your applied force. Okay, so that is how much you got it as 8 Newton. Now acceleration is, we know that what is force. Force is nothing but mass into acceleration. This formula everybody knows. Force is mass into acceleration. So acceleration is nothing but force upon your mass. So this is nothing but your net force. We have already written in the previous class. Anytime you want to find acceleration, it's nothing but the total force upon your mass. Total force, okay, whatever it has been after calculating. So first we'll see what is F net. F net is obviously both are in the opposite direction. So this will be total force, okay. So 10 and this would be minus 8. That is 2 Newton. So therefore, what will be acceleration? Acceleration is nothing but meter per second. Why there is acceleration answer we got? Because the body is moving. See, it's understood. Looking at the diagram only, it's understood the body is in motion. Why? If imagine this applied force was smaller than this, obviously friction would stop the block. But now what is happening? Your applied force is more than this. So it's your force is enough to push the block. That's why it is moving and that's why I got as acceleration. If this was less, no, then the body would not be moving. It would have been negative. If you remove this force, then this would have been negative. We'll solve one problem whenever we remove this force, what value we have to take for acceleration. As of
Teacher,
now,
how did
then
teacher how did 4 come?
4 is the mass, no? Yeah.
Okay.
Okay, you want to write the formula again? I'll write the other way. So this is F net, so that we got 2. Your mass is nothing but 4 meter per second. One more similar problem I'll solve. Just give the diagram. Suppose we have this case. And this angle is suppose 45 degrees. This is the applied force F, main F. And for this, mu of K is given to me as 0.3. Kinetic friction is given as 0.3. Calculate, find normal, kinetic friction and acceleration. Now, if it was simply a normal force, it would have been directly in the horizontal direction. But whenever there's an angle, you have to always resolve this into two components. So one will be a horizontal, okay? So this F will be, this will be a two main components. This is suppose a main F, so this will be what? This is your theta. So horizontal will be always F cos theta, vertical will be always F sin theta. To calculate that value, F is nothing but 10 root 2. So this is 45 degree. Sin 45 is nothing but 1 by root 2. This will give you 10. That is 10. Same way, calculate F sin theta. So this will be 10 root 2 into sin 45. Same answer here. Again, because sin 45 is also 1 by root. So both are 10 newtons. So the moment you resolve this component, the main vector into two components, this fellow will go. So we have to redraw the diagram. Okay, same 4 kg only you take. So this will be 4 kg block. Now only the components you write. Before that, which are the other two forces? Anytime for a block, that would be mg, there would be n. These are the compulsory ones which are always there for any block kept on a surface. Now other than that, this forces components are also there. So one will be what? Either you write on the same line or at the side, no problem. This is 10 and your vertical one is there. That is 10. Vertical, this is the horizontal. This is already by default present for the block. These two came into picture because this was slanting. So we resolved it into two components. Vertical also we got as 10, horizontal also we got as 10. Now, first thing what we'll have to do, calculate the normal n for this particular diagram. So now, in the previous case, what was happening directly, n was equals to mg. But now n will not be directly equal to mg because there are two. So as per the rule, we know that the total vertical force is always equal to the opposite side. So now both are in the same direction, both arrows, so they will get added. If they were in the opposite direction, then it would have got minus. So now this plus this, n plus 10 is equals to mg. N plus 10 would give me 4 into, consider gravity as 10. N would be 40 minus 10, n is 30. We got n, that is the first part. Then we have to calculate friction, f of k. This is given to me as 0.3. This I got as 30. This is Newton. Huh? This n is for the normal and this is for the Newton. So this will give me 9 Newton. So kinetic friction is 9 Newton. And the last part we have to calculate acceleration. Now for acceleration, we have to make sure we are writing all the forces, even the kinetic force also. So again draw the same diagram. Again draw. Now which side is the motion? This has been pulled this side, so body is moving this side. So obviously you have to draw the arrow always in the opposite direction. So this will be a f of k, which is nothing but 10. 9. Sorry. Acceleration is nothing but f net upon mass. If you forget the formula, remember that force is mass into acceleration. Keep a there only, bring m down. F net means total forces. So this would be what? 10 minus 9. Next one, same like this one only. Now force is applied this side. This is 45 degree. This direction, okay. Same 4 kg. Mu k is 0.3. This is f is given to me as 20 root 2. 45 degree only. Okay, there are two ways to resolve like this type. The one you can do like this. We will deal only with the arrows. This is 45 degree. Arrow is this side. So one horizontal, the components are always towards your arrows, okay. If the arrow is moving like this, it would be like this. If the arrow is going out, then these are also going out. If the arrow is coming in, then these are also coming in. This is one way to calculate this. Or All you have to do is, this is 45 degree, no? You just consider this line, this. So this will also be 45. So as per that, the components will be like these two components. So this would be V. So what is that? F cos theta. This would be F sin theta. Same thing. This is F cos theta, F sin theta. Basically, both the cases you saw that the direction is not changing. Where this vertical is going downwards, where your horizontal, this is cos, okay? This is sin. Where your vertical is going downwards, where your horizontal is going towards your right hand side. Look at this one. This one is also going same as this direction. And vertical is going as same. So whether you solve like this or like this, both mean the same. Same values you will get, same direction you will get. Okay, so either you calculate from this point or this point, both the ways, the direction. So this is anyways going towards minus y-axis. This is going towards positive x-axis. This one is also going towards positive. This one is going. This is same. This and this is same. So whichever you want to use, no problem. That horizontal component will be 20 root 2 into cos 45. That would be 20. The same would be for your vertical component. Now suppose you want to mark on this one. Now these forces are already there. One is a mg, one is a n. These are compulsorily there. Now we'll mark this one. This is coming down. So either you draw like this or like this. These both mean the same. Okay? Either you draw like this or down. But arrow should be pointing down, irrespective. So I'm marking this component like this. And horizontal means this side means definitely it will be or here. This is a n, this is a mg, or you can draw like. Both the ways you will get same answer. First we'll calculate the normal, same thing, same quantities. Okay, we'll have to calculate. First we'll calculate what is the normal. So looking at the diagram, you have to calculate the normal. So vertical force is always equals to vertical. So in this case, what is happening? They are in the opposite direction. Okay, so we have to take negative. One if you are taking positive, the other one will be negative. So you have to, if this you are taking positive, this one will be negative. Is equals to mg. N will be 60. In this case also same thing you'll get. See, n would be what? This side what it would be? Mg plus 20. Both are in the same direction. This I've solved for this diagram. If you had used this diagram, mg plus 20 would be equals to your n. This would give you 40 plus 20. Both case 60 only you would get.
Means for diagram there are marks.
No, no, that is only for your reference. But at least show, okay? Otherwise it will look copied. Whether it's you're drawing a rough diagram or whatever, at least it should be seen at the side, because without drawing diagram directly, it's difficult to understand. So whatever you're showing, don't show it on a different page. Just show it wherever you're solving the problem, so that your teacher knows you're not copied. Okay. Friction would be mu, and then mu same thing 0.3, and then this would be 60. No, same diagram. I'm not drawing. Okay. Not needed actually to calculate friction, only horizontal would be needed. So this is 20. Now the force applied is this side, so definitely this is your main force F. Okay, that is a horizontal component, and in the opposite direction would come your 80. Whichever direction you're drawing the arrow, opposite you have to draw this. So your acceleration is nothing but F net upon mass. So 20 minus 18 upon 4. Now next question. Next is little applicative type. You have to understand. Okay, this is not direct substitution. Now this is what only the diagram has been given. 4 kg. This is new S has been given for this one. 0.2. Calculate frictional force and acceleration. Now if you notice, nu of S has been given. Static friction. Now we don't know which friction means whatever which frictional force has been asked to calculate. Just said calculate a frictional force. So first now you have to try to understand whether the body is moving or not moving. If the body is not moving, then it is definitely a this what is that, static friction. But if it is moving, okay, then it is kinetic friction. So how to know whether it is moving or not moving? So before that, what we'll do is, if we want to know moving or not moving, so we write and keep, we don't know whether body is, if it was said body is in motion, then definitely you know that it would be kinetic, but now nothing has been mentioned, so we don't know whether the body is in motion or not. Or whether it is at rest, we don't know. But we know that when the body moves, only when your applied force is more. Okay, the force which I am applying has to overcome this. Your applied force should be greater than your frictional force, static frictional force. Only when you cross that limit, then only the body will start moving. So basically, we have to calculate your f of max and see whether it is more than 6 or not. So to calculate that formula also I have given, same formula it is. This is the basic formula you have to know. Accordingly, you just have to change the letters. This is the main formula. So now for maximum, this would be what? F of s, you just have to write it as max. And this would be static friction, so mu s. We have to use this formula to calculate this maximum and check whether it is more than that. If it's more than this one, it will not move. But if it is less than your applied force, then the body must be moving. So first we have to calculate this. For that, we need to know what is the value of n. N, everybody should know to calculate the basic diagram. So you know that n is equals to mg. Now substitute that n over here. Mu s is already given to you as 0.2. That would be 8. Now you got your max, and F means this is nothing but a applied force. Now see what is happening. Your applied force is less than this. So it's like how your body is there. You are applying 6 Newton on this side, okay? But your the frictional force is what? Fs max is how much? 8. You have to cross this in order for the body to move. So you know that your F applied, that is 6 Newton, is less than maximum. That is how much you got? 8 Newton. So the body is moving or not moving? Looking at this condition. Tell me, is the body
Not
moving?
moving.
Not moving. So this is anyways the frictional this. What is that? Force, which you have already calculated. Right now is 8 Newton because there is no more other this. So body is not moving. If body is not moving, what will happen to the acceleration? You asked to calculate acceleration. So what is going to happen to the acceleration? Body is not moving.
0.
Yes. That is body is at, you can also say body is at rest. So therefore, acceleration is 0. So the only friction which is there is so both is. If the body was moving, then we have to calculate kinetic force. Right now, there's only one force because if body is not moving, definitely there's no point calculating kinetic force. So the only frictional force which is there is the static friction force. That is 8 Newton. Another question, similar one. We'll see. find a frictional force and acceleration. Again, same case like previous problem. We don't know whether the body is moving or not moving. So whenever like this is given, always find your Fs maximum first. In order to calculate Fs maximum, we have to calculate n value first. Okay, so we don't know. We want to know whether body is at rest or motion. So for that, calculate Fs max. For that, what you have to know? N. So draw the diagram. Then 2 kg. This is mg. So we know that N is equals to mg. That is 2 into 10, which is 20 Newton. Now, I told you, this is what you have to remember. So we are calculating Fs max. Just edit it, put Fs max here. So if it's S, so that will be S here. Mu S already given to you is 0.6 in the question. N is 20. What is the applied force? 20 Newton. I'll just write here. Applied force is 20 Newton. You have to compare both. So this you got as 12 Newton. Which is bigger? Looking at the answers. This is your applied force, F. So this is greater than this. So is the body moving or at
Yes.
yes, the body is moving because applied force is greater than F of max. So what is happening? You are applying more force than what this one can oppose. So you have already overcome his force. The body this cannot oppose you anymore. So obviously the object is moving. Therefore, body is moving. It is in motion. Obviously, in motion means what will come into picture? Kinetic friction. So now you have to calculate a kinetic friction. K it will be. Same formula. Just put K at both places. Mu of K already value is being given to you in the question. That is 0.4. This value. N we have already calculated. That is 20 Newton. So this is the frictional force now. And now acceleration will be there definitely because the body is in motion. Now acceleration is not zero. Acceleration you have to calculate. The acceleration is nothing but F net upon mass. Again, we have to just modify. We have to check all the forces. This side is 20. Now this is opposite, 8 Newton. Frictional force will be there because the body is in motion. So F net will be 20 minus 8. Upon the mass. Okay, so acceleration is this, and frictional force Fk is next problem. Suppose the block is like this. This is the surface. 1 kg. This is 40 Newton. This is the applied force. Mu S, mu K, 0.3, 0.2. Find force of friction and acceleration. This is slightly a different case because earlier we used to have that horizontal surface. Now the surface is vertical. We'll try to draw this diagram. Now, very important. This irrespective, whichever side is the block, you know that gravity always acts downwards. Mg will be this side. Okay. Now, till now we were solving problems where Mg was this side and this was N. Always opposite to Mg, we used to take N. Okay. But remember, starting also I had given you under one note, N is nothing but normal. Okay. So normal is something you write and keep, okay, for this problem. Normal is always nothing perpendicular to the surface. So why is to draw that? Because normal is to be perpendicular to the surface. Now which side is the surface? This side. So your normal will be here. Always perpendicular to this side. Okay, so remember, anytime you have a block like this, it's normal, you have to always draw perpendicular to the surface of contact. Here it was normal, here it was okay because coincidentally this was anyways mg because it's vertically downwards gravity. Now we have to draw a line perpendicular to the surface, so opposite it has to become. But in this case, they will not be opposite. Simply just because our other problems were drawing exactly opposite, don't mark normal like this and keep. This will be wrong. Why? Because normal will become parallel then to the surface. You have to always draw normal itself. The word normal itself means perpendicular. You have to always draw it perpendicular. So remember that. plus there's one more force which is already there, that is 40 Newton. So we have to calculate N. So basically what it may looks like, it's like this is your 1 kg block, this side is N. You can draw like this or like this. It means the same, no? This is your mg. So as per that, straight away opposite forces are always equal, and will be straight away 40 Newton. Or you can take like this also. If nothing is there on this side, no, there's no force this side, no. So N minus 40 will be equals to 0. For this one, you can take like this also. There's no arrow this side. You are taking this two on this side. That would be N equals to 40. Or straight away N is equals to 40. Whichever way you calculate, N you will get as 40. We got N. Now we'll check. Again, we don't know whether the body is in motion or not. We'll check Fs max. 0.3, that is 12. So obviously 12 is less than 40. That is 40 Newton is more than. So if this is more than this, body is in motion. The body is in motion means kinetic friction will be there. We have to calculate this. Mu k is given to me as, oh wait, 1 second. Which side will be the body in motion? We'll have to calculate that for the diagram. 1 second. This will not compare with this one. The diagram is this side now. You be careful now. In this case, this was 40. Okay, this was your N. This was 40. Now, obviously, whenever there's a this, wherever it may be the surface, because there's a gravity, the body will not start moving this side or that side because it's on the surface. It's like the brick is against the wall. So obviously, it will be, the motion will be either this side or upwards. Okay, so you can say the block moves upwards or downwards now in this case, either this side or this side along the surface. So the motion is what? In the vertical direction, not in the horizontal. So we cannot compare with this force. because your friction will come always tangential to the surface. So your friction is already either this side or this side along the surface. Okay, we can never have a frictional force in the perpendicular, so we cannot compare with that 40. So we'll have to calculate this force then. What is the gravity force? So that is how much? 1 kg has been given. So 1 into 10, which is 10 Newton. So now what gravity is trying to pull the block down. So what will happen? The frictional force will be in the opposite direction. So we'll check with this one. We have to compare and see with 10 Newton. So the force applied is now gravity. That is how much? 10 Newton, which is still less than that is 12 Newton. So your gravity is still not able to pull it down because that it is somewhere attached to this. Okay, the moment this gravity, if this was around 2 kg suppose, then this would become 20. Okay, then the block would slide down. But right now that it must be comparatively light and there must be something attached to it, so it is not sliding down because 10 Newton is not enough. The gravity is not able to pull it down because the frictional force is 12 Newton. So this is less than that, the body is at rest. The acceleration will be 0. Okay, so remember for vertical case, you have to compare it with this one. So what is happening? This fellow, this force is trying to keep it attached to this, but your main force is trying to pull it down. The frictional force is always against your this. So we have to compare it with this and this. Because if we are comparing it with 40, then it's like you are drawing f of x this side, which is perpendicular to the surface, and under the notes we have strictly mentioned your frictional force can never be perpendicular to the surface. It has to be tangential, means in the horizontal direction of the surface, along the surface. Any doubt in this? You can ask them. Let's stop here.